sorry, this one, copy previous component, copied it, and we have to give a distance of 1650. So this should come in slope. You can visualize it by having a north view. This line looks in slope, right? And you can also check the coordinate if you like. So Q, you can just do QU and go to previous elbow, QU, right? 373 and 357. So definitely the elevation has come down. So we are at this elbow, and if you want to continue, it will take the some angle. The 1:100 will continue, but if you want to change, 1650, then you get okay, and elbow should now be directed to north direction in order to obtain a slope of south to north. So by default it is north only. So even if you click north, it will just round off the slope value because it was some larger digit, but slope remains same, 1:100. And then we have to move through the tail, copy another elbow. So we have to copy existing elbow and move through the tail. But since the leg is sloping, there will be more than one solution to it, because when we move through the tail, it will give you some options. We'll understand that. Just let me. Okay, so we have to first copy the elbow, copy current elbow, and we have to move through the tail. Now first, before moving, you should visualize how it is. So if I move this elbow through the tail, so which plane it should intersect? So this has to be, because if you move, it will give you multiple options. So if I move it, so it moves in some slope, right? It will continue into 1:100 slope, and it has to intersect this tail. So what kind of, let's say it is little bit, I, I, I am specifying slope like this, although it will be down, but let's assume this is down only. So it should intersect a plane. And what is the direction here? Let's assume, okay, direction is already given here. So a plane, what are the possibilities of plane through the tail? A plane, sorry, there is some problem with my software. So a plane can pass through tail, which is in north direction. That is, this is the direction of first plane. Let's say this one. Or a plane can also pass perpendicular to the, that means so I am making you understand beforehand. A plane can pass perpendicular. Is this looks perpendicular or not? No. Let's say a plane can be perpendicular. So either it can meet the tail here, or say meet the tail plane here, or it can meet the tail plane here, right? So, but in normal circumstances, when there is no slope, there is only one possibility. The perpendicular plane is similar to the northing plane, so it does not give you any options. But here, if we move this elbow through tail, so let's see what option it does give. See, it gives plane north, plane up, and perpendicular plane. Plane east is not active. So why plane up is also possible? Because a plane can pass, which is in upward direction through the tail, and since it is going down, it is going to meet this line is going down. Actually, I have shown this towards east, but it is going down, so it may pass that plane, right? So intersection point might be somewhere over at some other place, right? So these are three possibilities. So when you move through tail or through some component even, and this line is in slope, you are going to get this direction, these options. So accordingly, the intersection point will be different. Okay. So here, select the solution for north plane. For 9, for this training, we are going to select north plane, but see, I'll tell you, this is perpendicular plane. This is the position of northing plane. And this is, see, it is going to meet at a very long distance. If, because line is going into slope and a plane which is in upward direction is going to meet, see, it makes the plane. If you make it up, it shows a up plane. So when the elevation of falling elbow matches the elevation of tail, then it is going to meet. This is the up and this is the perpendicular plane. And north plane is not, it's shown only at tail. I know this is a little difficult to understand, but please ask me to repeat if you didn't get it. This is imagination, okay?